Okay, so you should be seeing on your screen the Unit 6 quadrilaterals and polygons. The priority standards to prove theorems about polygons. Today we're going to specifically look at what is a polygon and like how to find their angle sum. So down here, polygon angle sum. First off, what is a polygon? We're going to write a polygon is a closed 2D figure with straight edges. A closed figure, or I guess we should say a closed 2D figure with straight edges. Basically, a square, a triangle, a pentagon, a hexagon, octagon, things like that. We are not talking about circles because those don't have straight sides. I was just gonna see. We are still recording. Okay, I couldn't see it at the top. A regular polygon is the one we do see these more often because people in art, we find them pleasing to the eye. So like a stop sign is called a regular polygon. These things are equilateral and equiangular. Equilateral, if you remember from last chapter with triangles, that means all sides are the equal. And equiangular means all angles are equal. So equilateral, all sides are equal. Equiangular, all angles are equal within the shape. Quadrilateral is a four-sided shape or polygon. I guess we wrote the word figure. There's two types of polygons in general. We have convex and we have concave. A convex is a polygon for which there is a line containing a side of the polygon also contains a point in the interior of the polygon. So basically, there's no like diagonal. I think we got these switched. Okay, these are in the wrong box. Sorry about that. I was like, that does not make sense. Those are switched. Concave is when something caves in. So this picture is concave, right? That's caving in. And that contains a point in the interior. This is interior or inside the shape, kind of. So that is down there. Convex is a polygon for which there is no line contains both a side of the polygon and a point on the interior. So no side is caved in. Sorry about that. Put the picture in the correct spot, but the definitions are in the wrong spot. So we're going to look at this, and it says explore polygon names and angles. So how does the number of sides of a complex polygon, n meaning the number of sides, relate to the sum of the measures of the interior angles? So what you're looking at here in the first one, we have a triangle. A triangle angles are 180 degrees, so one triangle equals 180 degrees. If you have four sides, you can draw a line here, which creates two triangles in that four-sided shape. And two triangles would equal 360 degrees. Maybe I should put that below it. Okay, so now we have five-sided shape, which is called a pentagon. But if you start at one point and draw some dotted lines connecting the corners, so basically I'm connecting that one corner here to every one of these, whether it's, so this one corner, drawing a line from it to every other corner in the picture created 1, 2, 3 triangles. So 3 triangles. Hopefully you can start to see the pattern. If each triangle is 180, I would just add 180 more, so that would be 540 degrees would be how many degrees all the angles would add up to in that. So let's look for the pattern now. One triangle was 180, 2 triangles, 3 triangles. So I know the next one should have 4 triangles if I look at the pattern. And I know that should be 720 degrees. But what I'm trying to see is how does the number of sides compare to the number of triangles each time. So if you compare the number of sides to the number of triangles every time, the number of triangles is always 2 less than the number of sides. So the formula we're looking to come up with is you take the number of sides times minus 2, because the triangles are 2 less each time, and then we're going to times that by 180 degrees, because a triangle is 180 degrees. So down here it says how many triangles are formed drawing the diagonals from a vertex in an octagon. So we would have to know that an octagon has 8 sides. So how many triangles that would make? It's always 2 less. So that would give me 6 triangles. What is the interior angle sum of that shape? So we would take 6 triangles times 180 degrees, and that would give us our answer. So 6 times 180 is 1080. So the polygon interior angle sum, these are the angles inside, is written in terms of n. N is the number of sides minus 2 times 180 degrees, because it's basically the triangles times 180. The corollary to this theorem is the measure of interior angle of a regular polygon would be, remember the word regular means all the sides are the same and all the angles are the same. So if all of these things are the same, you just take your formula, your n minus 2 times 180, and because they're all equal, you can just divide by n, however many there are. So this one gives us an example. What if we have 11 gon? So 11 gon, n equals 11. So the formula I would say, in this regular polygon, if I want to find one interior angle, I'm going to do 11 minus 2 times 180, because remember n is how many sides it has. And then we're going to divide that by 11. When you enter this in a calculator, just to kind of give you a heads up, what you want to do is you want to do what's on top first. So 11 minus 2 is 9, times 180 is 1620, and then you want to divide by the 11. So I know the total, now I'm going to divide, there's 11 angles to divide that up into, which comes out to about 147.3 degrees. And it's okay to get decimals. We're dividing by weird numbers. You're going to get weird answers. But just round to the nearest tenth on those. So some of these types of things you probably have heard of before. Like a 3-sided figure is called a triangle. This is about naming polygons. Polygon just is something with many sides. 4 sides, quadrilateral. 5 side we call a pentagon. 6 sides called a hexagon. 7 is called heptagon. And I've also seen heptagon as written as septagon with a S instead of a H. And I did Google and both are acceptable. 8 is called octagon. So all these are pretty much prefixes that you might see in other words. Now, 9 nonagon is not one that's very common. And 10, though, 10 is common. Decagon, like a decade is 10 years. Decagon would be a 10-sided polygon. You'll notice all of these have, most all of them, have GON on them. They're a type of gon. And some of you guys might have seen in my classroom, I have the dodecahedrons hanging up. A hedron means a 3D, and gon refers to like a 2-dimensional object. So the last one on our list here, 11, hendecagon is not commonly used, but you may have heard of dodecagons. Some of these, the more sides, they get a little harder to draw, but those are at least how you name them. It's more so that if you have a question like on the ACT and it asks you about a pentagon or hexagon, just so you recognize some of these words and how many sides that means. So in this right here, you see Polygon's exterior angle sum. We've talked about interior angles are in red here, what's located inside the interior angles, what's inside. The exterior angle is on the outside. And they're wanting you to show you that the interior and the exterior angle always add up to 180 degrees. This is a video, and I'm sure you're not going to type in that website, but this video shows as these angles get closer and closer together, as they come together, it makes a perfect circle. And so, because it makes a perfect circle, the exterior angles of a polygon is 360 degrees. Okay, if you want to just find one individual exterior, you take 360 divided by n, the number of sides. All right, before I go to this next part, I think I'm going to stop the video so you can go back and write down those formulas, look at those formulas, and then we'll start the next video.